The cosmic journey. From the Big Bang to galactic destiny. We reside within a vast spiral of stars and dust called the Milky Way, a galaxy teeming with hundreds of billions of suns. But how did this cosmic home come to be, and what lies ahead for it and for us? These questions draw us into the grand story of galaxies, the majestic building blocks of the universe. Across the observable cosmos, there are roughly 200 billion galaxies, each a unique tapestry of light, motion, and mystery. Where did they originate? How do they function? And what fates await them? If you're captivated by the wonders of the universe, consider subscribing to our channel for more cosmic explorations. Picture the Milky Way, a colossal disk stretching across space, its swirling arms cradling countless stars with a glowing heart at its center. This galaxy, roughly 12 billion years old, is just one among a multitude. Galaxies are immense gatherings of stars, some hosting tens of billions, others far more, acting as stellar cradles where new suns are born from clouds of gas and dust, known as nebulae. Many of these stars are orbited by planets and moons, weaving intricate systems within these galactic cities. For centuries, humanity's understanding of the cosmos was limited. A mere 100 years ago, we thought the Milky Way was the entirety of the universe. That changed in 1924 when Edwin Hubble, peering through the 100-inch Hooker telescope atop Mount Wilson, spotted faint smudges of light in the night sky. These weren't lone stars, but entire galaxies, vast and distant beyond our own. In a single leap, our view expanded from one galaxy to billions. A revelation that reshaped astronomy forever. Take the Pinwheel Galaxy, a stunning spiral with over 100 million stars wrapped in graceful arms. Or consider the ancient elliptical galaxy M87, its golden glow a testament to its age. Then there's the Sombrero Galaxy, its brilliant core framed by a dark halo of dust. These celestial wonders, spinning like cosmic pinwheels, showcase the diversity and beauty of the universe's architecture. Galaxies are vast beyond comprehension. While we measure distances on Earth in miles, astronomers use light years. The distance light travels in a year. The Milky Way spans over 100,000 light years, with our solar system nestled 25,000 light years from its center. Yet, compared to some galactic giants, it's modest. The nearby Andromeda galaxy doubles that width, while the enormous IC 1101 stretches 6 million light years across, dwarfing our home 60 times over. But how did these titans form? The story begins 13.8 billion years ago with the Big Bang, a moment of unimaginable heat and density that birthed the universe. In that chaotic infancy, galaxies couldn't exist. There were no stars, no structure, just a searing expanse. Yet, within 200 million years, gravity began its work, pulling matter into clumps that ignited as the first stars. These pioneers coalesced into the earliest galaxies, faint and irregular patches of light. The Hubble Space Telescope has given us glimpses of this dawn, capturing images of galaxies as they were billions of years ago. The light we see today left those distant realms long before Earth existed, offering a window into their youth. In the Hubble Deep Field, we see fuzzy specks, embryonic galaxies forming a billion years after the Big Bang. To peer even further back, we rely on massive ground-based telescopes, tracing the evolution of these cosmic infants into the intricate systems we know today. Gravity sculpted these galaxies over eons. From chaotic clusters of stars, gas and dust, it forged orderly spirals and smooth ellipticals. The Milky Way itself emerged from the merger of smaller formations, its spiral arms flattening out as gravity wove its components into a cohesive whole. At the heart of most galaxies lies a supermassive black hole, a gravitational titan driving the orbits of nearby stars. In our galaxy, this black hole spans 15 million miles, its influence felt across the chaotic core where stars whip around at 1 million miles per hour. Fortunately, at 25,000 light-years away, Earth remains safe from its grasp. Yet gravity alone can't explain why galaxies hold together. Enter dark matter, an invisible force proposed by Swiss astronomer Fritz Zwicky in the 1930s. Observing galaxy clusters, he noted they should fly apart under gravity's rules, unless something unseen anchored them. Dark matter, estimated to outweigh regular matter 6 to 1, forms an unseen scaffold, cradling galaxies and guiding their formation. We detect it indirectly through gravitational lensing, where its mass bends light from distant stars, warping their shapes in our telescopes. Galaxies don't stand alone. They gather in clusters which link into superclusters, cosmic webs spanning vast distances. The Milky Way belongs to the local group, a modest family of about 30 galaxies, with Andromeda as its largest neighbor. Together, we're part of the Virgo supercluster, a sprawling network of thousands. But these structures aren't static. Galaxies move and sometimes collide. In 5 to 6 billion years, the Milky Way and Andromeda will meet in a galactic dance, merging into a new entity dubbed Milkomeda. Stars will scatter, gas clouds will ignite, and our galaxy as we know it will vanish. What does this mean for Earth? We might be flung into the void or swallowed into the new galaxy's core. But a greater force looms: dark energy. Unlike dark matter, which binds, dark energy pushes, accelerating the universe's expansion. Discovered just decades ago, it's a mystery, possibly a property of space itself. In the distant future, it could overpower gravity, stretching galaxies apart until they fade from view, leaving a cold, empty cosmos. For now, though, the universe thrives. Galaxies foster life, and ours has nurtured us. Earth sits in a galactic Goldilocks zone, not too close to the radioactive core, nor too far from the star-rich arms. This balance has allowed life to flourish, and if it works here, it might elsewhere. With billions of galaxies, the odds of other life seem tantalizingly high. The cosmos keeps surprising us. 20 years ago, who'd have imagined we'd photograph a black hole or confirm dark energy? We live in a golden age of discovery, perched on the edge of a galaxy brimming with secrets. Galaxies are born, evolve, collide, and fade, and our fate is tied to theirs. They crafted the elements in our bodies, and their story is ours. Once, we knew only our sun's planets. Now, we've found rocky worlds and gas giants orbiting distant stars, each born from the same stardust as our own. NASA's Kepler telescope has spotted over 400, from scorching giants to frigid rocks, hinting at a universe teeming with variety. Our solar system's 8 planets, 4 rocky, 4 gaseous, emerged 4.6 billion years ago from a swirling cloud, their differences shaped by chance and chemistry. Earth's water, Mars's deserts, Venus's infernos, all trace back to that violent birth. And what of the universe's age? Scientists peg it at 13.8 billion years, a figure honed by studying the cosmic microwave background, the Big Bang's faint echo, and the retreat of distant galaxies. Edwin Hubble's 1920s observations showed the universe expanding, a clue Georges Lemaitre first tied to its origin. This age frames everything: the rise of stars, the dance of galaxies, and perhaps the emergence of life beyond Earth. The universe's tale began with the Big Bang, not an explosion, but a sudden expansion of space itself. From a hot, dense point it grew, cooling into quarks, then atoms, then stars. Cosmic inflation stretched it vast. The first stars lit the dark, and galaxies took shape. Today, it races outward, driven by dark energy. Will it expand forever into darkness, collapse in a crunch, or tear apart? We don't know yet. Supernovae punctuate this saga. Stellar explosions scattering heavy elements like gold and iron, seeding new worlds. The last in our galaxy dazzled in 1604. But more await, their light poised to pierce our skies. They're destructive yet creative, a cosmic cycle of death and birth. This is our universe, vast, dynamic, and alive with questions. As we probe its depths, we uncover not just its past, but our own place within it. Thanks for joining us. Stay curious, and we'll see you next time.